Hi friends, in this video we are going to discuss about armature reaction for synchronous motor. You know armature reaction of alternator, right? Now the armature reaction for synchronous motor, how it is. Let's see. First of all, what is armature reaction? Armature reaction nothing but simply effect of armature flux on main field flux is called armature reaction. For example, at no load condition, nothing but my armature current is zero, nothing but my armature flux is zero. Hence, at no load condition, there is no armature flux, therefore, no armature reaction. But when load connected, IA comes into action, which produces the armature flux, which going to disturb the main field flux, that is taken as armature reaction. In synchronous motor, for example, this is the EMF. This is my EMF vector, which is reference here. Then our main field flux is 90 degrees lagging to the EMF. Whenever current carrying conductor placed in a magnetic field, what is the angle between them? 90 degrees. Right? Here EMF and the fluxes are like this. Now here case 1. What is case 1? Pure resistive load. Pure resistive load, nothing but what is the power factor? Exactly, unity power factor. Nothing but at this condition, what is the phase shift between IA and E? Exactly, in phase to each other, my armature current and EMF. This armature current produces the armature flux. Once observe the diagram, this is my main field flux direction and this is my armature flux direction. Are you okay? Okay. So, in generally, this is my main field flux direction, but after 90 degrees, this is my armature flux direction. Both the fluxes are like this. So here, what is the effect of armature reaction? If the armature flux is in opposite direction, demagnetizing. If it is in same direction, magnetizing. But here is this like this. So this is called a perfectly pure cross magnetization. Pure cross magnetization effect of armature reaction. This is simply the armature reaction case 1. In this condition, there is no increment in flux, there is no decrement in flux. Hence, here we are taken as a normal excited condition. The machine is at normal excited condition only, normal excitation. This is simply for pure resistive load, the armature reaction effect. Okay? Next, case 2. Case 2 is pure inductive load. Here I am taking that pure inductive load. Pure inductive load, nothing but what is the power factor? Is 0 power factor lagging is our power factor. Let's see how actually if the EMF is here, our main field flux is here, and pure inductive load, nothing but 0 power factor lagging, nothing but 90 degrees lagging, nothing but my armature current is here. If armature current is here, armature flux also in the same, armature flux also in the same. Okay, then see here, What is the effect of armature reaction? Observe here, this is the direction of armature flux and this is the direction of main field flux. Both are in same direction. Nothing but both are in additive manner. Yes or no? See here, both are in phase to each other. For example, this is the main field flux and armature flux also in the same phase. This is the armature flux. Both are in same. Hence, this is a perfectly, what is the armature reaction? Pure magnetization effect of armature reaction. When the pure magnetization takes place, the flux increases, but in order to maintain the same terminal voltage, here, what happened? Very good. Under excitation will take place. This is the machine operates at under excited condition. Pure cross magnetization, nothing but normal excitation. Pure magnetization, nothing but under excitation. Even in motor and generator, in both the cases, the answer is same. And next one, case 3, pure capacitive load. Let's go for case 3. See here, for example, this is my EMF and this is my main field flux. I am taking case 3. Case 3, nothing but pure capacitive load. When this is a pure capacitive load, what is the power factor? 0 power factor leading. Nothing but 90 degrees leading will take place, the current and EMF. This is my EMF and 90 degrees leading, nothing but this is my armature current and as well as this is my armature flux. Once observe here, this is the direction of armature flux and this is the direction of main field flux. Here two fluxes are in opposite direction to each other. When both are in opposite direction, what is the effect of armature reaction? Very good. Pure demagnetization effect of armature reaction. If the demagnetization will take place, then flux reduces to get the same flux, to get the same voltage. The machine operates at over-excited condition. So here the excitation is over-excitation. This is the armature reaction for case 1, pure resistive load, case 2, pure inductive load, case 3, pure capacitive loads. But we have another 2 special cases, RL load and RC load. Let's go for RL load. See here what happened for RL load and RC load. Let's derive for those 2. So case 4, resistive and inductive load. For this condition, what is the armature reaction? Tell me, for example, this is my EMF and this is my main field flux. When the load is RL, nothing but the power factor is just lagging power factor, nothing but the power factor angle is in between 0 to 90 degrees, in between 0 to 90 degrees. So here my armature current is some power factor angle phi. This is my armature current and this is my armature flux. Are you okay? So here, if the main field flux is like this, then armature flux is like this. Nothing but some part of the flux is adding, some part of the flux is crosses. So tell me, what is the effect of armature reaction is here? Very good. Here the effect of armature reaction is partially cross magnetization and partially magnetization. This is the effect of armature reaction. Whatever, if it is magnetization that is operating at under excitation, this is the excitation at this condition. So, RL load, partially cross magnetization and partially magnetization. And what about case 5? Let's go for case 5. What is that case 5, sir? Yeah, very good. The case 5 is the RC load. Now tell me, what is RC load? Yeah, very simple. Here the power factor is leading. Nothing but the power factor angle is in between 0 to 90 degrees leading. So how the diagram once see here, this is my main field flux and this is my EMF. Here 90 degrees and 0 degrees, in between 90 degrees and 0 degrees. For example, my armature current is here as well as my armature flux is here. Yes or no? So observe here, this is main field flux direction and this is the armature flux direction. Then what is the effect of armature reaction is here? Some part is opposite direction, some part is crossing. So tell me, what is the armature reaction? Partially cross magnetization and partially, tell me, very good, demagnetization effect of armature reaction. This is simply the RC load. Whatever, if demagnetization takes place, the excitation is over excitation. This is simply the armature reaction for special cases, case 4 and case 5. These are the armature reaction points for synchronous motor, which are very important for parallel operation, remember. Are you okay? Getting or not? Now let's see the overview. What is the overview of synchronous motor armature reaction? See, very simple. This is my EMF and this is my main field flux. If armature current is here, that is called unity power factor. That is called pure resistive load. Then the armature flux also here and the armature reaction is cross magnetization and the excitation is normal excitation. Right? Very good. If armature current is here and armature flux is here, tell me what is the load? Very good, very good. Pure inductive load. Next, what is the power factor? Very good. Zero power factor lagging. What is the armature reaction? Very good. Demagnetization or magnetization? Magnetization effect of armature reaction. And what is excitation? For magnetization, the excitation is under excitation. That's good. If armature flux and armature current is here, if armature current is here, what is the load? Very good, pure capacitive load. What is the power factor? Zero power factor leading, that's good. What is the effect of armature reaction in opposite direction? In opposite direction, nothing but very good, pure demagnetization. And what is the excitation? Over excitation. This is what? Over excitation, under excitation, normal excitation. If they given like this, they given like this. This is RL load or RC load? Very good. This is RL load. Nothing but lagging power factor. Partially cross magnetization, partially magnetization will take place. Cross magnetization, magnetization. So here also under excitation. If the curves were given like this, for example like this, whatever it may be, these two are the RC load, nothing but leading power factor. What is the armature reaction? Cross magnetizing and demagnetizing. So partially cross magnetizing and partially demagnetization effect of armature reaction. Then what is excitation? Yeah, demagnetizing, nothing but over excitation. This is a simple diagram to completely remember the armature reaction of synchronous motor. Getting or not? Are you okay? Right? Let's see. Let's see a quick review for this. For example, they will ask you a question. At pure resistive load, what is the power factor? Unity power factor ultimately? Yes or no? What is the armature reaction? The armature reaction is cross magnetization. What is the excitation? Excitation is normal excitation. For example, pure inductive load. What is the power factor? Yeah, exactly, zero power factor lagging. What is the armature reaction for synchronous motor? For pure inductive load, that is magnetization, and the excitation is under excitation. Next, pure capacitive load, what is the power factor? Very good, zero power factor leading. What is the armature reaction? Very good, demagnetization, and excitation is over excitation. This is for synchronous motor. For example, they ask you alternator. For pure resistive load, what is the power factor? Wherever you go, pure resistive load nothing but unity power factor. Pure resistive load nothing but cross magnetization. Pure resistive load nothing but normal excitation. Everything is same for alternator and synchronous motor. For both these two values are same. And this is for motor. Let's what the same values for alternator. For pure inductive load, even though pure inductive load in alternator, the power factor is same, but armature reaction is here demagnetization. If it is demagnetization, the excitation is over excitation. So here these are interchanged. These two are interchanged. You should remember these two. And this is for motor. And tell me for alternator. Let's do for alternator. For pure capacitive load, zero power factor leading is same. But here, this is a magnetization. If it is magnetization, excitation is under excitation. Here also, these two are interchanged. Just interchanged. The pure inductive load is equals to pure capacitive load. Pure capacitive load is equals to pure inductive load, like that. Just interchanged. This is for motor and alternator armature reaction results. I given only for 3 cases. Remaining 2 cases you have to write here. For remaining 2 cases you have to write here. How the changes are there. Are you okay? This is the armature reaction of synchronous motor, and this is the armature reaction for motor and alternator. What are the differences? Is it clear? Right? Thank you.